Right. Let's see. Okay. Day 14, Advent of Code. Yeah, so I will have done all the half of the Advent of Code 6, so that's nice. Odin. Let's copy paste something from one. Why not? Up. Up. Sample. This. This. And let's reopen it. Odin run. Okay. Day 14, parabolic reflector dish. You reach the place where all of the mirrors were pointing, a massive parabolic reflector dish attached to the side of another large mountain. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. This system must be what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes, pulleys, and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes, depending on their position. The weight of each rocks deforms the platform, and the shape of the platform controls which ropes move and ultimately the focus of the dish. In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt it one of 4 directions. The rounded rocks will roll when the platform is tilted, while the cubed-shaped rock will stay in place. You note the positions of all the empty spaces with dot and rocks, your puzzle input, for example. This. Start tilting the lever so all of the rocks will slide north as far as they will go. So okay, those 4 get concatenated. Just checking that I'm still alive. Those 2, those 3, okay. So the round one just get stacked all the way up as far as they go, as far as they can go. It's a bit. I think I implemented something like that when I implemented the 2048 game, where when you swipe, you merge the number that are the same, but if they are not the same, they just go as far as they can go. I mean, it's not very complicated. And the cubed shaped rocks. What do? They just stay in place. Okay, they are constant. And so if I tilt north, this one will go there. Okay, so the cube-shaped rocks cannot be moved. They're like walls. Okay. You notice that the support beams along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load of the north support beams. The amount of loads caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform, including the rocks, the row the rock is on. don't contribute to the load. So the amount of load caused by each rock in each row is as follow. 10, 9. The total load is the sum of the load caused by all the rounded rocks. In this example, the total load is 136. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on the cube channel. So the amount of load caused by zero is as follow. I'm so confused. So the north beam is damaged, and we need tell the platform so that the rounded rocks all roll north. Afterward, what is the total load? So we just need to go in one direction. I guess part 2 will maybe like move in multiple directions. And so we just multiply, so that's 1, 2, 3, 5 times 10, 50. 50 plus 8, 18. Yeah, that looks like this. I want to make sure I understand the problem, so I will just manually do it because I can't read apparently. So it's 5 times 10 plus 2 times 9 plus 4 times 8 plus 3 times 7 plus 6 there is nothing, 5 there is nothing, plus 3 times 4 plus 1 times 3. Okay, that's exactly it. Okay, that doesn't look too complicated. So the example puzzle input is this. Xclip example. Let's get the real puzzle input while I'm at it. Up. Xclip input. Up. Okay, so Odin run. Okay. Example. Let's see. So again, I just need a dynamic list of rules. So, and how do they call it? A platform? Tell the platform. Okay, I will call it a platform as well. Platform is equal to dynamic array of rule, like so. And for line in strings, split lines, iterator, s, like this. And we do happens platform, and we happen actually, but it's good. I need UTF-8, UTF-8 from string to rooms, yes. Just line. Just line like this. And we need to defer delete platform. And since this allocates something, I think we also need to for row in platform do delete row. Okay. Let's make sure I print it. Let's make sure I have the correct input. That example. That looks correct. Okay. Then actually I'm too lazy to like find what's the URL. I would just like to check Let's see, 2042. That's a game, right? Clone from home. No, it's not there. 2000. Oh wait, is it 2048? Forgot what the game is called. No, no. Ah, it's 2048. 2048. Clone. Is it there? Yes, it is. Okay. How did I solve this? Maybe I should go back to this one. CD git 2048. How did I solve this? I think it was in game, I guess. Speed stop. Oop. I made it in C++ because I like pain. So I have a row, and I just copy pasted the code 4 times because I'm an animal, but in this first part we only need one direction, so it's fine. And let's see how I did the up thing. So row, and then I do row pushback, and then merge row. Then I assigned it to where is merge row? So current size, if row, pivot, different 0, pivot plus plus. I guess but we don't need to merge in this case, it's just that row I is equal to 0. Ah, yes, okay. So I iterate over all the elements, and I have a second loop that starts at where the that starts as where the last rock is, and I do a shift from there. It doesn't sound too bad. That doesn't sound too bad. And actually I have to do this from the north. But I think I will do a function like I did before, where it's let's call it roll proc, and we're gonna have a slice of rune, which will be called I don't know, row, and we return. I guess if I modify this, it will stay modified since a slice is a pointer. Don't really need to return it. And the way we do this is we do last actually we could just count until the edge, or count until a cube-shaped rock. How do they call it? Rounded. Rounded count. It's equal to 0, and we do 4. I don't know. 4 are in row Let's just call it x because I don't care. If x is equal to this, do the rounded count plus equals to 1. If x is equal to this, we need to shift all of them. I think I will need an index for this. I think I will need an index, and what we need to do is I will import slice. And I need to do this, and I will do slice fill. Then I need a row from let's say last equal to, let's call it top, for like the top of the pile of rock, the current top. It starts as top until I, because we don't want to override the cube shape one. And we want to fill this with just empty. And then we want to slice, fill, again, row, top. And I guess here it's we don't have to fill all of it. I guess we don't care about optimization for now, so let's just do it that way. And we now want to fill from top to rounded count. No, from top plus rounded count like this with rounded rocks. So we remove the previous one and we fill it again. And we want to do this at the end of the loop. So if oh, but it's not I, it's just the end. The end. Okay. That should be alright, I think. That should be alright. And so for the actually for part 1, that's actually most of it. Huh? I just transpose this to get columns instead of rows. And then I apply this function to each of the columns. And then I just count it. I mean, I just do the total load computation thing. So collect total load and its platform, which is a slice of runes, and it returns an int. Expected a type. What? Ah, yes. Let's. This doesn't need to be a function. I need to do platform transpose is again a dynamic array of. I guess it's also dynamic rule like this, and I need the same thing. Transpose transpose like this. And here it's column. And I'm too lazy to. Wasn't it day 10 where I have a transpose? Yeah. We already have a transpose somewhere. Transpose. It's actually it was just day 13. Transpose. And yeah, indeed, I don't have to make it dynamic. Up. Platform transpose. Yeah, I'm way too lazy to like rewrite this. So platform. Where was my day 13? Pattern transpose. And this is how I did it. So let's just paste this and pattern by platform. And is it as easy as this? I think it will be. Except it's like this. Okay, let's see. That looks correct. Let's see, 2, then the dot, then the dot, then at the very end this. Okay, that's exactly what we want. Then we do for column in platform transpose. We want to roll column. Actually, I don't know if I can do this. Oh fuck, all the... Okay, so first of all, I forgot to set the top. So top is equal to I plus 1. And I also need to -1 here. So I'm overwriting all the cubed shaped rocks. But besides that, the rolling itself seems to be actually working. Like there is 4 here, there is 3 here, which is correct. Also, rounded count, I think we need to rounded count, we need to set it back to 0 after we roll it. So it's gonna, let's see, it's gonna count all the rounded rocks. And let's say there is no cubed rocks in this world. It's gonna fill from the, fill from the top, which is 0, so all of it was empty. And then it's gonna fill from 0 until 0 plus rounded rock count by rocks. Let's try this. Okay, and there should be 3. Okay. Now, if there is a cube-shaped rock, let's say first we break. Oh, right. Okay, maybe let's ignore the last one. No, that's still not it. I'm struggling to find the correct algorithm. So this is like pretending that cube rocks don't exist. But when, okay, let's set top here. Yeah, okay, my bad. I have some stuff like this. Let's print ln row here. (24), this one. Is out of range of yeah, and I need to reset the counted block. Let's print it here, maybe. Make it will be easier to read. So the third one. Okay, so it works only for the last one. So yeah, that makes sense. Then what we want is fill like this. And fill this like this. And this is what we want. Let me double check. Yeah, that looks about right. There's 2 there. Yeah, okay. Okay, let's remove the prints and okay, so we roll for all of them. Actually, we need this. Sum is equal to 0, and then we do for x I in col do sum plus equal to so the start has to be multiplied by len col minus I. Okay, it's a bit more complex than this, I think. If x is a rolling this mismatch type binary expression round versus int. Yes. Yeah, that seems decent. I have to print and sum. Oh, that's a good answer. Let's go. Let's check if that works on inputs. Okay, it's bigger. It's a bigger number. Let's see. That's the right answer. Let's go. Okay, first let's make it slightly more optimized. No. I don't care. I will do that at the end. If I reach the end, let's not jinx it. Up, right. Okay. Part 2. The parabolic reflector dish deforms, but not in a way that focuses the beam. To do that, you'll need to move the rocks the edges of the platform. Fortunately, a button on the side of the control panel labeled spin cycle attempts to do just that. Each cycle tilts the platform 4 times so that the rounded rocks roll north, then I knew it, it's gonna roll in multiple directions. Tilt the platform 4 times so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. After one cycle, the platform will have finished rolling the rounded rocks in those 4 directions in that order. Here is what happens in the example above after each of the first few cycles. After 1 cycle, after 2 cycles, after 3 cycles, okay. This process should work if you leave it running long enough, but you're still worried about the north support beam. To make sure they'll survive for a while, you need to calculate the total load on the north support beam after a lot of cycles. 1 billion cycles. 1 billion? Yeah, maybe there is some optimizing to do, but 1 billion seems fine. It's like we have to do 4 billions. Yeah, that sounds a bit tricky, but I don't know. It seems brute forceable. In the above example, after 1 billion cycles, the total load on the support beam is 64. Run the spin cycle for a billion cycles afterward. What is the total load on the north support beam? Okay. So we have to do north first and then east. Let's go. So it goes north, then west, then north, west, south, east. Okay. And so north is just a transpose. Then west is the regular one. South is transposed reverse, and east is reversed. I mean, where each row is reversed. Okay. Let's create a new function that is called roll direction. And let's create an enum, direction enum, like this, and we do direction north, and then south, west, and east, like this, and this is a block, and this is a platform, like so. And it's gonna do, actually it doesn't return anything, but we still need to compute what was it? The score, total load. Total load is also a proc that takes a platform like so. And it does this, and return sum. It's called total load on platform transpose. Oops. Uh, uh, and let's have a thing that is platform transpose, takes a proc, platform, it's again run and returns like this. Up, 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 blah, blah, let's call it PT platform transpose of platform, like so, like so. Refer let's do like this, PT, PT. And there is no delete, and we return platform transpose. Like so, and sum, cannot return sum, right? This returns an int, and this is just platform. Get assign value. I think I can do this. Ah, fuck. Where did I go wrong? Where did I go wrong? Oh wait, no, I rolled it. Fuck. I need to not roll it. I guess we can do this here, then do this like this, and then we do PT. And we don't roll anything here. Fuck me. Example 104. Let's print count type platform. So it's not even rolled. Why? Oh, oops, this is PT. Okay, and so up inputs. Yes, okay. Where did I have a print? Print here. That is fine for part 1. Okay. Then what we want is roll direction. So we want, I think, to have a switch on eyes. We need direction, which is a direction. We need to switch on direction up, like so. And case direction. Direction. Direction north, because we already know how to do it. That is how we do direction north. I think we will need to optimize by not doing so much allocations and modifying the current platform, but okay. So, yeah. Then we need to assign to platform. I guess we could like not care about memory leaks for now and just return the new platform. Then we have case direction south, which is I think the same thing, but we do like this. We need to do slides reverse call. Okay, like this. Actually, let's do slice reverse call. Looks a bit cleaner. Then we have direction west, which is actually direction west. It is just platform, nothing else. And direction east is we reverse the thing, and that's actually row up. Let's row as well. And, row. And you have to reverse first. And this is platform. And it's strange that it cannot infer that this will never happen. But let's do panic. Just panic direction. Okay, so can I do pt is equal to roll direction of platform, and I do direction north, like so, and I need to do it like this. Yes, okay, that works. Next, so that's only for part 1. That is only for part 1. And not handling the allocations properly will definitely not work in the real example because it's a billion. But what I need to do is how many? So just for I don't care in from 0 to I don't know. Let's see. So he does how many cycles? He does. Let's say just one cycle, and we do for direction in. Can I iterate on direction like this? Ooh, I can. Okay. But I need to order them correctly. So it's north, then west, then south, then east. Okay, and let's take back the example. So I do this, and then I do platform is equal to role direction platform direction, like so. Cannot assign value to dynamic. Can you assign like to a slice like this? Cannot assign to platform. Can I just do p is equal to platform like so, then p and then p like this. I have the example. Yes, I didn't print anything. Print ln p. Actually, let's do for row in p do printf p and wait, let's why? Yeah, okay. Okay, I see. I think I need to put it back to north every time. Which is annoying, but makes sense. So it would just be that's even more wasted allocations, but what can you do? Yeah, I really hate doing this, but I really hate doing this. That's actually fine. And no, but why is it so messy? Yes, I'm printing Pro. After one cycle. I think I mixed up some stuff. I think I mixed up some stuff. Uh, Maybe my transpose stuff is just too complicated. I mean, I wanted to implement it in a way that I could keep this role function very simple, but the complexity is just become like coming out in this end, and it's also not optimized at all. So maybe I should just roll with a direction here and put the complexity here. Sorry. Uh, So if direction is west, it's fine. So this is currently direction west. If direction is equal to direction east, it's quite simple. We just do slides, reverse, row, and that's the same. Let's just make this for now. The tricky part is if that's direction east or direction south, because if it's going to the south, we will need to reverse it as well. Uh, that is quite tricky. And after it's passed, we need to reverse it back. Ah, but actually that's only on a single row, so I cannot... yeah. I cannot do the transpose thing. Wait, let's go back. Let's go back and let us do... So west is fine. Then here I feel like doing call is equal to make a slice of runes that is of length platform 1. Yeah, that's fine. Then 4 row I in platform do how do I create a transpose again? Do it like this. Platform transpose I. So I have a column and then I iterate over column and then I iterate over. I need to fill this column. So I need to do for x is so for j in it goes from 0 till len platform 0. So that's the indices number. And I need also to iterate for I in platform. I think it's fine if I just do this. I just want the indices and I do call. So it's column j I. Sorry, is equal to platform I j, and that can be in a do because we just fill it. Cannot index call of type rune. Yes. So it's just this. Actually, no, it's just this. No, it is just this. And that needs to be actually j. Oh, I'm so confused. No. Yes, no, yes, no. No, it can't be like this. It has to be like this. But I feel like this is a bit fucked. What do I do for j in platform transpose? Let's just do call. So I have the index of column is j, so that's 100% sure. Is of length platform 1. No, we want it to be a column, so it's length of platform. Yes, and then it makes sense. I think it does. And then I have a column, and I want to do row of column like this. Okay. And I want to do total load on load row. Actually it takes a row like this, and then you just do this. You have your total load row. Yes. Actually, what the fuck am I doing? That wasn't my ID. My ID was that, so I make a duplicate, I make a new one for the column, but now I need to modify the original, which is, again, this, but then I set it back, like so, and that's how we do it. That's how we do it. And so now the original platform will be rolled in a direction, and I will have just made one allocation. Defer, delete, call. Like so. And let's ignore all that, and let's do partial. Wait, no. Partial, like so. And what we want to do is not this for now. We just want to test that it works. And let's do platform transpose of platform, since platform should have been modified. Again, like so. Invalid direction 59. Direction north. Where do we only use direction north? That's strange. That is strange. Ah, yes, I need to return. Well, actually, there is no need to panic. And there is no need to return either because it's modified in place. That looks like the good answer. And then what we do on input, just to double check, that is a good answer. Okay. Okay. And it's way more efficient than doing the whole transpose thing. Then what we want is let's implement west because it's easy. And we don't have to return. Okay. Let's implement south. So south is a platform, so is a column. What the fuck am I saying? Need to copy paste north. So it is a transpose, but just before we roll it, we need to slice reverse. And I have to make sure in the documentation that slice reverse is actually in place. For slice reverse. And I mean, there is no allocator, so I guess it is. Yeah, and if it's not, I will eat my hat. And actually, I don't even need to do this. I can just do reverse like this. Can I? Can't I? I'm not sure actually. And since I'm not sure, let's just do slice reverse because it's easier. So I reverse it here, and then I reverse it back here after the thing, and then I set it back. So transpose it, reverse it, roll it, then unreverse it, and then untranspose it. That looks accurate. And then for in machin, okay, so it's like this, except we have to do the reverse thing here and here, and it's no longer a partial switch. Whoops. Can I switch window, please? Yes. And now let's do this, and let's do this, and actually, let's just do platform, like so. Platform, Uh, oh, that looks right. Let's print it for x in row. Do print x, except it's a print like this, and here we do println. Oops, println. Because it's hard to see. So let's see how this compares to the first cycle. So there is 4, 3, 4, 3. Yeah, okay, that looks good. And then I have to do this for like 1 million. Total load on million cycles. Okay. Oh, 1 billion. Okay. Let's do 1,000 and see if my stuff is fast. Seems like it is. Let's do 1 million. Ah, fuck, it's already struggling. Okay, oh, speed. Okay. And I need 1 billion, is that it? Actually, let's just copy paste it for sanity. Up. Up, I need this, I need this, I need this, and I need this. Yes, it's 1 billion. Let's see for the example if he manages to do it. I guess it should take 1,000 times what it took before. So... and that's only the example. Huh? The actual input is a lot more rows and a lot more columns. So actually it's only 100. So that's not too bad. Okay, so this is slow. This is slow. And 1 million was what time? Wait, 1 million is like really easy. So it took executed in 2 seconds. How about 10 million? Because like this is linear, so this took 13 seconds, so this should take 113 seconds. This should take 130, which is about 2 minutes. So yeah. And I don't want to wait, so let's try to optimize this. So this is 13 seconds. Or at least it was. Yes, it is. Let's try to see if I can't do my slide optimization here. What was the slide optimization? So here is stop plus I think. Plus I minus 1. Nope. I know I can do that, but Actually, it's not top plus I, it's just I. No? Wait. No, 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 no. That is correct, but here is where we fill it with top plus rounded count. Let's put spaces here. Okay. Oh, it doesn't take... sorry. Doesn't take less time. Takes more time. Oh, well. That sucks. Are you sure? That's because I set less values. Strange that it takes... Okay. I guess it's not that much. Can I replace this by... partial switch on X, and we do case. If it's a dot, we just continue and don't care. Case, if it's an O, we do this. Case, if it's this, we do this. And syntax error because I need this. Can only be used with an enum type. Okay, so it's a switch. Okay. And this is not really faster. Is this actually slower? It is. How? Because it should like continue early and treat do less stuff here. Okay. Can I do if rounded count greater than 0? Can I do the filling thing faster? That did make it faster. Let's add this same condition here. Okay. So maybe removing this allocation everywhere and just making it call of rune, this. And what we do is we just allocate it once. We do it like so. And we do call like this. And we do, yeah, I guess we can have call here as well. And so that will make it easier because we allocate only, we are allocated only once. Or will it? Yeah, it made it 1 second faster. The reversing thing, maybe that can be put here. Okay. And yeah, I mean, obviously the question is, should I keep do like a micro optimization after micro optimization like this, or should I find just a smarter way to compute the thing? I think I don't know. I feel like the small optimization by small optimization way will eventually work. So like here we're already at 10 seconds. Can I try like 1 million, for example? So this take nothing, but if I use the inputs, let's see. I just want to approximate how much time it would take. Okay, this takes. Come on, buddy. Come on. Come on. And the problem will be, I mean, I can keep doing like small optimizations like this, but I don't think I can parallelize this. It's a very sequential, it's a sequential thing. Oh fuck, it's already struggling for like only 1 million. Huh. What if 10 times less, let's see. Actually, oops, let's do like so. Let's do an easy one. Okay, that he can do. Can do 10,000. It can do 100. Can you do 100,000? You can. So it took 23 seconds and Python, what was it in time? Is that 1 billion? I think that is, yes. Divided by E1, E, and it's 5. So we need 10,000, it will take 10,000 this, so 23 times 10,000. Well, yeah, obviously. So it's 230, okay. Divided by 60, so that's how many minutes, that's how many hours. So it would take right now 3 days. Yeah, about a bit less than 3 days to compute. Which is a bit too long. I'm willing to like wait for an hour, but not 3 days. Hmm. I think we can make it faster by not using the slice fill, but doing a for loop. That's something. And I think we can improve it by, instead of using reverse, we can do a reverse loop like so. Let's see. Fill. Whoops. Fuck. Fill. Yeah. Is this optimized in any way? So the fill uses copy. And copy is array, what? If len array 0 is equal to value for I inferior len array I times 2. So it does increasingly larger copies. Wait. So array is the original array. And then I is powers of 2. Ah, okay, I see. That is cool, but why not just do like a mem set? I cannot do mem set because it's not it is not bytes. But there is a mem set with a specific size. I feel like this, like me doing a for loop would be more optimized than this. So yeah, let's do for loop. So for whatever this is, let's just call this j in, and it starts at this, and then it goes until I do row j is equal to this, and then the other one goes from top until this. So, and this is equal to this. Okay. Let's take the one that took this took 23 seconds before. Oh, that is incredibly faster. This is incredibly faster. Let's until len go. This is a lot faster, okay. And now I can even have proc fast, since I don't use a context. That is barely faster. But is it actually correct? That's because it might not be. Let's see. So here I did one cycle. Yeah. Yes. All of this seems correct. And let's try to do 10 million with the example. Oh, wait, no, I'm printing stuff. Wait. Why is it not? Yes, I'm breaking. I just want to time it. Okay, it's not too bad. That's not too bad. So this should be 80 seconds, which I don't think I'm willing to wait that long. So the next thing to optimize, so that seems to be correct. Let's add a slide comment. Not using slice fill. Not using slice fill because because why? Because why? Slice fill because oh, it took 70 seconds. Okay. And so we have 100 million and we only need one more. So the example would take 70 times 10, so 700. 70 minutes would take a bit more than an hour to compute. Okay. Again, not willing to wait for that long, but it's good to know that I'm reaching the example. Why am I not using slides? Because it's not optimized for my usage. Yeah, that's a bit vague. Also, can't use proc fast. It's it. Up. I think a thing that would make stuff go faster is if I replace runes by U8s. Can I convert conversion? Is there like a string conversion? String conversion. Oh. String conversion, where are you? String type conversions, yes. From string to X, yeah. To, yes, that's what I want. So I want to, oh, I can just transmute like this. That is cool. Okay, let's do this, huh? Transmute, and transmute is just type punning, if I understood. But let's replace rune everywhere by U8. And then here we do the transmute thing. And it's just line, like so. But we still want to allocate something, huh? So here I want to do row is equal to make U8 slice of length line, and then I want to do for character and row do row I is equal to, don't care about this, is equal to u8 line I, that also works, and then I do this row. Okay. And so I just replaced U8 by U8 everywhere, and it seems to be fine, like it compiles, and still the correct answer. Oh, come on. And so that was the thing that took 70 seconds. Let's see if it's any faster now. I mean, it should use less memory, so better, what do they say, cache? Like it can use more caching than runes. Yeah, doesn't seem a whole lot faster. Huh? What else? What else? What else? What else can I optimize? Do I still use this? Ah, yes, I do. It took the exact same amount of time. That's disappointing. That is disappointing. And I have a question about like the reverse iteration. What about the index in this case? How about the index? Because I need to set it as well. Let's see. Let's go here, vt.odin. Let's do package main, main is proc, and then I have an array, x is equal to an array of ints 5, so then I do reverse for x I in x's, and I do import core fmt fmt prints ln of ix. Odin run file. No, wait. t.odin file. So, oh, the index is also reversed. That is very, very nice. That is very, very nice. Or is it? I'm not sure actually now. I mean, otherwise there is other ways to, of course, to do a reverse, but I feel like they would be more cumbersome. So what if I do? Is a slice reverse optimized? Reverse. Oh, I don't want filter reverse, I just want plain reverse. Source, let's see. Len array, and it does swap, and it does the swap one by one. Swap array I and len array. Yeah, that is the good reverse algorithm. Going to put a hoodie. Mm-hmm. Yeah, I'm not sure. But in the meantime, I would like to maybe do the total load function again by copy pasting some stuff. So I need a column. I need for this. Like this. This is a row. And it's I. I don't need this. I think I don't need this anymore. And I don't need this. Okay. Just for the sake of having less code. Is there an Odin profiler maybe? I feel like slice reverse is fucking me up, but I'm not sure. And I would like to have this as fast as well, but I cannot do this. But the code for the reverse function is very simple actually, so maybe I can copy paste this. So, and it's a call, and this is an n is len call divided by 2. Let's not have this yet. And swap, where is the swap? Swap. Is there a swap? Oh, there is a swap. But it is a slice swap. And what is the source for this? Here. Swap when non-overlapping. Ah, I can just do this. That's nice. Can I just do call I, call this, up, up, is equal to this, this. This is getting messy, but I don't care for now. And what is wrong with this statement? Syntax error. Why is this syntax error? 54. Expected statement got a parenthesis. Oh, I have an extra parenthesis. Okay. Not sure if that's correct. So like this, and we do this. Yeah, that looks about right. Can we do this as a do? Like so. And can we have proper spacing? And then reverse it. And I'm doing that for this one, and reversing them as well, and then fast. And is this still the thing that is supposed to take 70 seconds? Yes. Let's see. So yeah, that's one solution. The other solution would be to do to not reverse like the whole slice, but to do the loop here in the reverse direction, which I think would be faster. Yeah, because we don't have to assign it every time. Yeah. Let's wait for a bit. Only 2 seconds. Only 2 seconds faster. Ah, fuck. Yeah, this was 70. Now it's 68. Okay. That's not great. I'm running out of ideas. I am running out of ideas. And what could the smart solution be? What could the smart solution be? When you shift the so you make it go north, west, south, east, and then so it goes in a circle like this. And I remember in one of the earlier puzzles, there was a thing where it's impossible to like actually simulate the thing, but since it goes in a loop, you have the like at some point you have the same result multiple times, you know? So I wonder if like maybe like you turn it 133 times, like a random number, and then it just repeats every 133 times. Actually, but I mean, I can check this, huh? Can I just do slice copy? Isn't there like a slice copy? Clone. Yes, there is clone. And I want to clone platform. And I want to clone it to P2. And what I want is if P2, I want to do slice all of rock. Ah, but it cannot capture it. I can do for a row in let's do equals true, like so. Row in platform row I, and then we do like so, and then we do for x j in row and we do if x is different than p2 ij e is equal to false, and we can break yeah, let's put it n. In variable declaration, like so. And we do if e is equal to true, we do this, we print it. If it's equal to true, we print it, and we break. Oh! Okay, so it does. Fuck. It does repeat itself. Let's change U8 to rune everywhere. Wait, that's not how it goes. That's weird. Ah, yeah, I think maybe this is not right, or the like one of my optimization is not correct. And also, I think so we iterate over all of them, and if one is different, we do that it's not equal. And this is horrible. Why have I written this? We set it to false. So that means that it should mean that it's it is exactly the same, but I think it's... What does clone do? Copy the slice into a new slice. It creates a new slice, it copies it, and it returns it. Yeah, that's what I want. Clone to dynamic. Yeah. Ah, but it's a slice of slice, okay. So I have to do p2 is equal to make slice of runes of len platform, and I do for I don't know, whatever row I in platform do p2 I is equal to clone platform just row. Yeah, okay. Okay, and apparently it never happens that and let's make sure my stuff works. If I don't roll it, it should exit immediately. Yep. Oh, wait, fuck. Wait. I have to remove that one. So okay, it takes it directly like this. Oh, this code is still needed. And yeah, that doesn't seem to work. I didn't keep the slice fill here. That doesn't work. It's strange that it doesn't repeat, huh? Should repeat at some point, no? I guess not. Hmm. So none of the positions are the same. That is bonkers. Hmm. Actually, there is one thing I can do in parallel. So I can do this. No, I can do this in parallel, like for each row thing. And I can do this in parallel, and I can do this in parallel. So I could go 16 times faster. I could go 16 times faster. No, actually, I could just go 4 times faster. But that is still not great. And that is very complicated as well. I mean, very complicated. Not really, but... doo-doo-doo-dum. Let's see. Focus the beam. Attends, slide control panel level spin cycle. Each cycle tilts the platform 4 times, and that north, west, east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. After one cycle, the platform will have finished rolling the rounded rocks in those 4 directions in that order. This process should work if you leave it running long enough, but you're still worried about the north support beam. To make sure they'll survive for a while, you need to calculate the total load on the north support beam after a billion cycles. In the above example, after a billion cycles, the total load on the support beam is 64. Run the spin cycle for a billion cycles afterward. What is the total load on the north support beam? Is there a cleverer way, I don't know if cleverer is a word, to represent the platform? I don't think so. It is still strange to me that there isn't a loop somewhere in the billion thing. It doesn't go back at some point to the initial formation. Actually, maybe let's. So the example is this. But maybe it's just because the initial setting is none of the 4 directions. So, like, if we just went north, actually we need to do this, shift it to, what is the order? Shift it to the east, copy that, and then after each cycle we check if it's equal to the eastern position. Then we know it's a cycle, because what I mean is, like if I try to make it equal to this, it will never be equal to this, because if, for example, we just look at those two, if we just went north, well, they cannot be there. If we just went south, they would be down. If we just went west, they would shift one to the left. And if we just went east, this one would be here. So this position is absolutely impossible to reproduce with a tilt. Okay. So what I have to do is I have to not do this, but do direction. I mean the last one. The last one is east. Yes. So I tilt it to the. Actually, I need to do this, but oops. Let's copy this here, but also comment it back to keep this. So I need to shift it to the east and then check if it's equal at some point. Still not. That sucks. That sucks. And just to make sure that again my condition is right, can I do this? And it should print 1. Oh, okay, so my this is not correct. Let's break here. Then he's supposed to do that 4 times? If direction, so 9, direction is equal to direction east. Yes, I need to do this. Like so. And let's do exactly this, but for P2. And maybe like so. This should be exactly the same. Oh wait, it's not, okay. If I do a reverse. Yeah, because we just did 3 things. Reverse is not supported. Oh, that's unfortunate. But let's say we start with east. They should be exactly the same. Yeah, okay. Whoa. But I wanted to test. If we start with east. Okay, so my equality thing does work. My equality thing does work. And yeah, apparently it never goes back to the eastern position, which is a shame. Wait, what? That makes sense. That makes sense. So it just did the 100 million position. I'm tempted to let it run for 2 days, to be honest, but now that I'm thinking about it, I didn't even I didn't even check that my replacement for slice fill is actually working. So maybe I should do that. So all of that is garbage. What I will do is at the very end, I will print it. And I'm only going to do 3 cycles. So let's see. Okay, already my stuff doesn't work, so that is at least something simple to do only 1 cycle. And it absolutely does not work. Okay, so actually we don't know if this is true because my algorithm doesn't work anymore. So let's go back to slice fill. Slice fill, what was it? Row from top plus rounded count. Wait, no, it's actually this, still I by this. And this is top. This is top plus rounded count by O. Like so. And this is this. And we can definitely not care about this. So this is just the length. And this has to have a context. And I can also not care about this. Still doesn't work. Still does not work. But that does look like what I had before. Huh? Let's see. Still the good answer for. Still the good answer. Yeah, for part 1, so the north direction is working. Yep, the north direction is working. So this is after 1 cycle. Oh, did I forgot to change? Oh, fuck me, okay. So east is at the very end, and this is this way. This is good, this is good, this is good, this is good, yes. Let's do 3 of them. Make sure that is good as well. That's good, that's good, that's good, that is okay, that is okay. Okay, it works up after 3 cycles. And now let's make sure that even with my optimization, it still works. That looks exactly the same. That's good. This back. That is exactly the same. And that is exactly the same. Okay, that's good. So at least we know that that works. Let's do one thing at a time. So let's make it fast. Same thing. Okay. So the reverse was wrong, maybe. That looks exactly the same. I wonder what was wrong if it wasn't that. That looks the same as well. Oh, okay, that one is wrong. S call by row. so. And it's back to being correct. Okay. And we can make that one fast as well. Then we need to do this. And we need to do a big number. And I'm not doing this, and I'm doing this. So wait, I'm confused. Yeah, but that's only easy. So I'm not printing this, and it should be good. Okay. Still nothing. How do I verify that this condition works? How do I verify that this condition works? Maybe let's do north first. Then it should print it. Yes, okay. Should print it like so. But we want east. I mean, I could generate 4 of those copies to the original and have like the original shifted in 4 directions and then check on each of those directions, but I think it doesn't matter because if I reach one of them at some point, the next ones are gonna be exactly like the cycle is gonna repeat itself. So let's say I check on 4 of them and I check on north, but instead I want to check only on east, like it will just do like 3 more iterations before it actually reaches the exact same point. So I think it doesn't matter. Okay. So maybe I can do move all of this outside of the cycle, so after each cycle. Okay, that doesn't seem to be happening. I mean, at least now I have a correct algorithm. I know that. But yeah. But yeah, it does not want to do it. It does not have a cycle, which is really surprising. Maybe not, but what other tricks do I have up my sleeve? Does not have a cycle. Could do the multi-threading thing, but making it 4 times faster. I don't know if it's even worth it. And I'm not even sure, like with the threading not overload, but overhead, that it would actually be faster. Yeah. There is not a single duplicate in 100 million iterations. 100 million cycles. That seems impossible. That seems completely impossible. Oh, and this is the final one? Wait. This is the only time I print something, right? Okay. So after 100 million iterations, it looks... Wait, I lost one of them. Fuck. I lost the rock. Because, yeah, I'm comparing to this, the third cycle. Because it looks exactly the same. Wait. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So 18. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, okay, I didn't lost one. It's just that this one, instead of being here, it's there. Oh, it's such a small difference. And like in 100 million iterations, it never goes back here. That sounds impossible. How? Let's do... let's print it every time, I think. Because, I don't know, I'm really paranoid that there is actually a cycle. Oh, I'm so confused. It looks exactly the same. Oh, wait, no. So this part is exactly the same. This is the same. This is not the same. This is the same. This is not the same. Uh, yeah, I guess there is so much combination, but I feel like like obviously not every stone can be at every single place, but there is like a reduced number of places the stone can be. So I would imagine that the combinations get reduced by a lot. Ah, Sabania, bidibi, badaba, bibou, baba. Hmm. Maybe. Uh, so I have the total load thing. Can I do a print ln total load of platform? And of course, at the end as well. I mean, it's always very, very similar, huh? But I guess the minimum maximum of this value is greater for the actual input. I mean, it seems to differ by about 10,000. Hmm. Let's do min load is equal to huge number max load is 0, and then come on. Because there is a, when you answer in the advent of code, I mean, this is like the disgusting way of doing it, huh? But in the advent of code, if you input an answer, it will say if it's actually higher or lower than the actual answer. So if I get the minimum and maximum bound, I can do some kind of manual binary search with the advent of code input field. I did that once in my life in 2021, I think, because I was desperate, and today I'm feeling a bit desperate, so let's do it. Let's do it as well. So where is my min-max? Oh, fuck. Fuck. It's weird that... okay, yeah, that makes more sense. So that leaves a range of a lot, actually. But at some point it seems to stabilize into a range of 10,000 or something. Let's do this. Let's have an I here, and let's do if I is greater than the first 1,000 iterations. Okay, that seems more like it. So that's yeah, that's about that is about 500. And I think I don't even know why I'm computing this. This is so stupid. But AOC 2021. It was 17 that I rage quitted on, I think. Where is my rage quit? 15? Yeah, okay, I remember. So I get six hints. Oh wait, no, I get 3 hints. Fuck. So like that's like 500 divided by 250 divided by 112, and then the last one will leave me with about 55 answer. Yeah, okay. Even with the hint, it's not enough. I would have to wait a long time. I remember this so well. Yeah. What if I do... No, the first 10,000. Does it stabilize into a better pattern? Not really. I could also start doing probabilities where I keep a map of the number of time I encounter this load, and I just guess the most probable one. I have no clue. But that doesn't sound good. Let's do it even more like this. I really need like a smart way of of doing this. It still boggles my mind that it never goes back to the initial position, since we're doing stuff in a cycle. Oh. Oh, okay. Hmm. What can I do? What can I do? What can I do? And with the example, yeah. With the example, it would be possible, but no. And so this means that after one cycle, 69 nice, but that means that like two different platform have the same exact load. After a full cycle, which seems strange, but okay. I guess I can print this as well. Let's try this out. Huh? So 69, 69. So those two platforms have the exact same score. It makes sense. 4 here, 2 here, 3 here, 2, 2, 3, 1, 1. So this one just went there. And that's it. That is it. Let's north. So it's north, west, south, east. North, west, south, east. Those two are going there. North, west, south, east. North, north, west, south, east. Trying to understand how is this correct. And this one on the in the top right, north, west, south, east. So this one is in a loop. That makes sense. And that, oh no, the T is not all the time in a loop. Mm-hmm. So there is no cycle and there is no way of brute forcing it, except waiting 3 days. But is there really, I mean, I keep going on with this, is there really no cycle, especially for the example? Because there is like so little variations between those, and I've tried for like 100 million. So I'm just looking at like 30 of them, and there is like very few variations. And it seems impossible that that they're like all different. Oh, but maybe it's like how do you say that? Isn't it like those decimal like those fractions that end up with like they start, let's say, like 14 point like 2 3 1, and then they repeat like but only part of it, so it would be 1 1 1 1 1, but it like it's still 0.23. So the start is a bit random and then the end is regular. Could it be that? Or at some point it goes into a pattern? Hmm. Uh, I'm not sure, but we can find out. We can find out. So what we would do is, of course, that would make the complexity of the application a lot worse. Previous East patterns is equal to a dynamic list of this. And then what we would do here is remove all this junk, and we do previous east pattern, and then we append this, and then we do C for copy. And then we need to do for previous in previous east patterns. Let's put that back here so that it's slightly faster. Like so. Yes. So it's not P2, it's previous. P2, it's previous. Is there P2 anywhere else? There is, but I don't care. Okay. Oh, let's go! Let's go! Okay, so there is a loop somewhere. Okay, but I need to go to the bathroom. Alright, I'm back. So there is a pattern. There is a pattern and I want to see it. And I want to also break. Let's name this. The first pattern that there is, I want to see it. So it's this one. So this is indeed exactly the same. Is it? Okay. So this is the start of the pattern. Yeah, and that's a bad name. It's actually previous list patterns platform. So there is a pattern, a repetition pattern, and just out of curiosity, let's print I to see when it starts. What? Oh no, that's not great. Ah, fuck. Okay, maybe I got excited a bit too much. Fuck me. I need to do this, but only after. No! I mean, I had hope. I had hope. Oh, never mind. There is a pattern. Let's go. So it starts at 9. Okay. So, and I need to do previous found counts. It's a bit weird, but basically want to like register the start and the end of the pattern. It's equal to 0. And here, instead of break main, do previous pattern count, we do plus equal 1. And we do if previous previous. Wait. Okay, this is getting a bit trickier. So there is a pattern. Sorry. There is a pattern. Okay, so I need one to keep the previous platform, and I need a thing of the pattern. Can't speak English anymore, doesn't matter. And I need a flag that says pattern started, which is false. And if we do pattern started is becomes true. And this only happens if not pattern started. We do all this. So while the pattern has not started, we check in all the previous iterations. Do we actually need to the whole pattern? So at some point I find that there is the start of a cycle. So here, for example. So that means that this position has been reached 2 times. And what I need to do is get a multiple of 1 million. No, like a number that we can multiply up to 1 billion. And then get its total thing there. Uh, I'm getting hungry as well. I am getting very, very hungry. But I think this is the solution, alright? We have something small to eat. Come on, brain, come on, brain. You can do it. You can do it. It's only day 14. But what I also want is previous J. Okay, so it found between the third iteration. Actually, is this the third iteration? Because we have it in the examples, huh? So yes. Okay, so the third cycle is the exact same as the 10th. Okay. So what I can do is because here I just got the end of the pattern. I mean the start of a new one, but so the end. So we know that the end of the pattern is the 9th, and the start is the 3rd. So I can get the length of the pattern by doing I minus j. That will give us 7. And now that we have the start, the length of the pattern. can we do 1 billion modulo 7? Like 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, modulo this. I guess this needs to be parenthesized. So it's number 6. And let's do like a quick and dirty thing. That is, if I is equal to 6, let's print it. Let's do this basically. And it should be 64. 65. Fuck. So it's number 6. How about I need to maybe +1 or -1 at some point? Yeah, I think since his stuff. Yes, okay. Since yeah, he starts indexing at 1, I need to do 1 billion -1. And so the only thing I need to do is instead of having a previous, I don't need this, previous is platforms that is just this, I need a struct that keeps track of the total load as well. So struct platform with load, and I forgot I am in Odin. Struct. So we have the platform, which is a rune thing, and then we have the total load, which is just an int, and this is a dynamic list of platform with load. And where do I append this? I append this platform with load of C is a copy of the platform, and we need a total load of C. And we need this, and that doesn't matter. And that doesn't matter. And previous of type. Ah, yes. Previous platform. Previous platform. And here what I need is I need previous. No, I need previous is platform at index this, and I need the total load. That should be 64. Fuck. Where did I go wrong? Where did I go wrong? So yes, and I'm appending this, and C is what I want. Yes, it's a platform, slice of slice. That will never happen. Let's remove some of this. Let's remove some of this. Ah. So for previous its platform, for row in platform. If E or I is equal to 9. Where is my... Is there an infinite loop somewhere? Wait, am I even here? Uh, okay. Am I doing this? Oh. Okay, so I'm never doing this. Ah. That makes more sense. Up. Okay. Except I also have to. There's a main tag. Break. Main. So. Fuck. 87. Uh. Yes. How to remove this? Okay, 64. Oh, that was painful. And so inputs. And can you like do this and do this? That doesn't sound correct actually. That definitely does not sound correct because at some point I did statistics and it was between two ranges and that's outside of them. Fuck me. Oh wait. This is gonna be annoying. Let's go. Fuck me. That's not the right answer. Answer is too low. Yeah, of course. Let's still keep track of it. No. Too low. Of course, it's too low. Of course, it's too low. Maybe I just got lucky. So J would be the end of the pattern. I is the end of the pattern. J is the start. Yeah. So the 9 cycle is exactly the same as the second one. And for the inputs, I mean, it's gonna be hard to read, but if I do this. So that means that the 134 cycle is the same as the 90. Actually, shouldn't it be I plus modulo of this? Let's see. Because so it should be I plus this. And also don't print. And let's try with the example. But that's out of range, of course. For this one. Wait, actually, I'm saying garbage now. Wait, J is the minimum. J is the start, so we need the start. That sounds more like it, but I don't think that's it. Fuck. 63. Yeah, this is good. Oh, fuck. This is going to be 7, right? Right. This is indeed 7. And so, I mean, we can also remove all that junk. We can remove all the junk. So, what happens is this. Putain de merde, j'en peux plus. So what happens is we have something that is a bit random, and then at some point there is a pattern. And what we have is we have a history. Let's make this a bit shorter. So this is real life, where there is a bunch of this, and we are here. So we've identified that this is a that this is the start and that this is the end, and we want to infer what is somewhere here. And so if the pattern started on the exact first iteration, so if there was not this, we would just have to find between this and this the so it would be 1 billion. You know what? In the meantime, let's just try this one. Let's try this one quickly. Yep. Fuck. Okay. That is. Your answer is too low. Okay. Just to get one more hint. Too low. And if I remember correctly, it was the maximum was 7,200 something. Okay. I don't even know why I checked, because if it doesn't work for the example, of course, it's not gonna work for the input. And so, yeah, this is a bit confusing, because here actually J is the start and I is the end. Ah, no. And here we just started the pattern and we found that it's here. So we can get the length of the pattern. And so if we do 1 billion modulo the length of the pattern, we should have what we want if there was no start to it. Because if this is, let's say, 1 billion is actually here. If 1 billion is actually here, maybe I need to do 1 billion minus this value, and then that value modulo the distance between those. So we shift 1 billion to reach 0, and then we compute the modulo on that. Let's do that. So let's do another print. So it is 1 billion, still -1, I think. And this time we do minus as well the length of it, so that's I minus j. And that's all this modulo the length of the pattern. And it's println. And let's do that on example. And if I do this for previous East platforms, and I go all this, and then I go total load, I get 64. Okay. And now I go to this, but for input. It's, oh fuck, that's not correct. Ah yes, because I still need to shift it. Let's go back to the example. So I do the modulo like this, but I also need, so the start is j, so that's a plus. Fuck. Fuck. So 1 billion minus the distance. Actually, it's not 1 billion minus the distance. What am I saying? It's 1 billion minus the start of it. 1 million minus the start of it, and then that's j plus this. Ooh. Okay. So I shift the 1 billion back, do the modulo, and then add this to the start. So reshift it back. Input. It's definitely higher. Let's try it. Ah! Yes! Oh putain, I fucked up my mic. Ah, man. That's the spirit of Christmas. Hell yeah! Ah, mon dieu. Holy fuck. Man, I had to really unlock all the garbage power of my brain. Oh, man. Fuck's sake. Oh, man. Wait, I need a few seconds of break. The spirit of Christmas is really strong. The spirit of Christmas is really, really strong. Alright. Let's remove the garbage. Yes. Let's remove the garbage. And let's explain a tiny bit what I did. Shift, one bill, back to 0 by doing minus pattern start. Modulo that by the length of the pattern, then shift it back by adding pattern start. Okay. And actually, if I do this, I think it should be exactly the same answer. Huh? Yes. Yes. Because I'm gonna shift it north twice, but doesn't matter. It does not matter. It does not matter. Can I remove all the weird optimizations as well? That would be nice. And up. Next. Call. Well, let's call. Don't need a call. Okay, that's a good answer. And then can I do this, this, and this, and remove the first. Can I run it without speed? Yes. Alright, all of these shitty optimizations for nothing. That feels good. I mean, it's not often the right answer, so I shouldn't be too surprised. Okay. And we can just do like so. For previous J. Can we do nice all of rock platform? No, I cannot do this. But here I can. Slice equal row and previous platform. Right. If not equal. Yeah, that's the same thing. I'm going to simplify it a bit more. Who cares about breaking? That probably does not have an influence on it. Oops. And who found previous found in previous is equal to true, and found in previous is equal to false, found in previous. Let's do platform copy. No, platform clone. Platform clone. Platform clone. And defer deletes previews this platform and defer deletes for in previews this platform to delete p platform like so. Yeah, that is needed. Load to load. Too many values. Yes. Let's call it loop. Is there something else I need to clean up? Don't need this. Do I need this? Oh, it's weird that I don't need it. Yes, I can do UTF-8 strings to room 9, like so. Yes. All right. Anything else? Let's see. Let's run debug. Valgrind of 14. By slice equal. That's strange. Conditional jump or move depends on initialized values. Oh, okay. But otherwise, the slice clone in 120 is not this one. Yes. Boom, 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 boom. Let's do platform delete. Rule returns nothing and it does just this. Defer platform delete platform. Does that work? It does. Okay. And this one I don't understand. Uninitialized value. Row is initialized and previews platform I. Wait a minute. I'm a bit confused because I think it's this. Oh wait, no, it is this. We're comparing line by line. Not sure why Valgrind gave us a warning, but whatever. Can I say it's whatever? Conditional jump or move depends on uninitialized values. Memory compare. Alright, but good enough, huh? Good enough. Let's double check that this is the correct answers. The first one is correct and the last one is definitely correct. Okay. So yeah, that's it for this day. 3 hours and 30 minutes. It's... I mean, it's a bit after the halfway point, so... I think I'm gonna die when we're gonna reach day 20 and so on. Alright.